Hey everyone, welcome to another Coding on iPad Pro video. My name is Ryan, and today I'm going to show you how to create your very first SwiftUI and RealityKit app in Swift Playgrounds. At the end of this video, you'll have your very own AR app that can do this. It will be a great learning experience. This is a medium difficulty project, so I'm assuming that you're comfortable with coding and the Swift programming language. In this video, we're going to learn how to create a SwiftUI view, how to use RealityKit with SwiftUI, how to place AR objects in our physical space, and finally we're going to learn how to use a coordinator to enable the flow of data between a SwiftUI view and a UIKit view. So what you'll need to follow along with this video is an iPad, the Swift Playgrounds app, and optionally an external keyboard. And that's it. So without further ado, let's get started. Step 1 is to create a SwiftUI view. To do that, we're going to open up Swift Playgrounds and we're going to create a new playground. We're going to enter in code, and in this case, we're going to import a few libraries. We're going to import Playground Support, and we're going to import SwiftUI. Okay, so for this step, we're going to create a very basic SwiftUI view, kind of like a hello world example. So the first thing we're going to do is we're going to create our struct called content view, and we're going to adopt the view protocol. And in there, we're going to create a variable called body, which is a sum view. And this is very standard SwiftUI code. And we're going to keep it simple, so we're going to add some text, and we're going to say hello world. Okay? That's all we need to do to actually create a view in SwiftUI. But we also, in Swift Playgrounds, have to set the view for the page. And so we're going to say playground page dot current set live view to, and then we're going to create a new instance of our content view. Okay, so once we have this, we can run our playground, and there we have it. Hello world. It's as easy as that. In step 2, we're going to create a RealityKit AR view and bring that into SwiftUI. To do that, we're going to import our RealityKit library. And currently, there is no native way to create a AR view in SwiftUI. So what we have to do is we have to create a UIKit AR view and then wrap that around so that we can use it in SwiftUI. We're going to use a UI view representable to do this. And so we are going to create a new struct called ARViewWrapper, and it's going to adopt the UI view representable protocol. And this protocol requires a few things. One, we're actually going to use Swift Playgrounds to help us along the way. So as you can see, there's an error right now, and I'm going to say fix this error. What this does is it adds a type alias for a UI view type. The UI view representable needs to know what type of view we're trying to create. And so we're going to say AR view. And then we're going to have some more errors. So we're going to select again the fix option in Swift Playgrounds. And now you can see there's 2 more functions added. Just for organizational purposes, I'm going to put the type alias up top. And let's take a look at these 2 functions. So we have a make UI view, which returns an AR view. So this will likely be in charge of generating this AR view and then making this compatible with SwiftUI. And then we have our update UI view. This runs every time the view has to refresh. And so for now, we're going to leave the update UI view blank, but we're going to do all our work in the make UI view. In here, we're going to create our AR view. And so we're going to use a constructor provided by Swift Playgrounds, where we have a frame, a camera mode, and automatically configure session. For the frame, we're going to do .0. We can do this because SwiftUI will automatically infer the view size and will provide this to AR view. And so our AR view will automatically be configured for the size. Our camera mode, we're going to do AR because we're trying to create an AR view. And then we're going to say automatically configure. This sets lighting, reflection, plane detection. It just makes it very easy for you to get started. And so now we have that, and then we are going to return our AR view because our return type in this case is an AR view. Now this is as easy as it gets to actually create the AR view. we now have to bring this into SwiftUI. Now, this takes some care because in the body variable, there's only allowed to be one main view element. And so right now we have a text view. If I, for example, were to add an AR view wrapper in the main body, we're gonna get an error, right? Now this error doesn't really say much, but essentially we cannot have two views in the main body view. We have to somehow stack them, either horizontally, vertically, or even in the z-axis. So what we're gonna do in this case, we're gonna create a v-stack, and we are going to then create an instance of our AR view wrapper, which now is a SwiftUI view, and we're gonna restore our text view that said hello world. Okay, so that's what we have. Now make sure that you test your code often, because if there's any issues, you want to spot those quickly. And so we're gonna run our code, and now you can see the camera and hello world below that. For step 3, we're gonna learn how to place AR objects in our physical space. This is actually a pretty simple task to do. So in your make UI view, we're actually gonna create a very simple AR cube that we can place in space. And so let's actually start doing that. Below your constructor of the AR view, what we're gonna do is we're gonna create a model entity. A model entity is essentially an AR object, and it needs a mesh and a material. So we're gonna create a mesh using a mesh resource, and we're gonna generate a box of that has a size of 0.2 meters all around, so it's a cube. And then we are going to create a material, which is a simple material, and we're gonna use a constructor that allows us to provide a color, a roughness value, and whether it's metallic or not. We're gonna do a blue color with a roughness of 0.5, and we're gonna say, yes, it is metallic. If you haven't seen these values before, the roughness and metallic, I suggest you play around with it, get to know it, experiment, have some fun. Okay, and now we're gonna create our model entity, which will use a constructor where we have to provide a mesh and a material. In this case, it's an array of materials, but we're just gonna provide one material in our array. So we're gonna provide our mesh here, and here we're gonna just say our material in this, just a single element in the array. Now, any object that you want to put in the physical space has to be attached to an AR anchor, or in this case, an anchor entity. And so we're going to create our anchor entity. And for our anchor entity, the criteria that we want to use is that RealityKit should place our object on a horizontal surface. So we don't necessarily care where in the space, as long as it is a horizontal surface. So a tabletop, the floor, all of those would qualify. And so as soon as that is detected, it places the anchor, thus the model. And so we're gonna say we want it to be a horizontal plane. Now, very important, don't forget to add your model entity to your anchor entity. And so we're gonna say add child, and we're gonna say model entity. Now, there's one more thing that we have to do. We now have an anchor entity, but it has not been added to our scene. The scene is a property of the AR view, and so we have to do arview.scene, add anchor, and we're gonna add our anchor entity. And this is all that we have to do to actually add a AR object into our physical space. Now, let's see if it works. There we go. See, our blue cube has been placed into our space. Great. As you saw, it is very simple to create an AR object, in this case a cube, and add it in our scene. However, you may have noticed that we didn't have control over where the cube was placed. It was just placed wherever ARKit found a horizontal plane. And so if you want to essentially be able to control where the cube is placed, the code is a little bit more sophisticated. So let's take a look as to how that works. What we're going to do is we are going to create an extension of our AR view. There's really no way to do gestures right now in SwiftUI and to be able to actually place an object there, because there's no coordinates in the view to be able to pass that on to our AR view. And so we're going to use a UIKit approach in this case, and we're going to extend our AR view. And so we're going to create an extension. And the first thing we're going to do is we are going to create a function that allows for gestures to be recognized. And so we're going to call this function enable placement. And in this case, all we have to do is really just add a tap gesture recognizer to our AR view, that whenever the user taps on a specific point in the screen, that location is recognized. And so we're going to essentially add tap gesture, add gesture recognizer. Okay, we're going to add a gesture recognizer. And in order to do that, we have to create a tap gesture recognizer. So we're going to say let tap gesture recognizer equals UI tap gesture recognizer. And this needs two things. We're going to make our target just the self, and we're going to create a selector. A selector is really just a function that is called whenever this tap is recognized. And so we're going to essentially call this handle tap, and we're going to have that pass the recognizer into it. Okay, and so in our we have an error, unresolved identifier. That's fine because we haven't defined our handle tap function, so it's complaining that it can't find that. And then we're going to add our tap gesture recognizer into our add gesture recognizer. So this is how we essentially add a recognizer to our AR view that once you tap, the handle tap function is called, which will take care of object placement. And so let's actually define our handle tap function now. Now make sure that you add Objective-C, that keyword in front of it, because in order for the selector to properly work, that is needed. And so we're going to call this handle tap, and we're going to say recognizer, which is a UI tap gesture recognizer. Okay, so this is the function that we're going to use to essentially handle our tap. And as we see now, the error is gone. Great. So the first thing that we're going to do is we have to figure out the location of the tap. This is the location on the screen, because we have to translate that to a point in space. And so what we're going to do is we're going to say let location equals recognizer dot, let's see, that's the location in, and then we want it in our AR view. So we want to get essentially the 2D coordinates of the tap, and we do it by so. Now, the next thing that we have to do is we have to essentially use a raycast. So a raycast is like a laser pointer where wherever we tap on the screen, we want to send a virtual raycast to any real world surfaces or any detected surfaces. In this case, we want to send a raycast to a horizontal plane so that we can then place an object where the user wants it. And so we're going to create a raycast. So we're going to say the results of this raycast are self.raycast. This raycast will return an array of results, and so that's why we assign that a variable results. Raycast, and we're going to do that constructor, so a constructor that allows us to do it from a point, which is in this case our location, our screen location, 2D point, and allowing and alignment. I'll show you how to use these values. So we're going to say from our location, and in allowing, we have a few options. We have an estimated plane, existing plane geometry, and existing plane infinite. So an estimated plane, it's not quite sure that there's a plane there, but it thinks there's a plane. Existing plane geometry is very certain that there has to be a plane there. So it's a little bit more accurate, but it might take longer for that raycast to return. And then you have existing plane infinite. Wherever it found an existing plane, you can then on an infinite surface place your object. So even if the table ends, you can continue to use that plane. In this case, we're going to just use an estimated plane. We don't have to, it doesn't have to be that super accurate. And then for the final one, we have alignment. What we want to do is we want it to be a horizontal plane. right? Because we still want to add it to a tabletop. It's just now we want to be able to control where the object is placed. And so now that we have our results, then what we want to do is we want to get the first result. And we want to see if the first result, so the first thing it hits, if that is a horizontal surface. And so that's what we're going to do. We're going to essentially say if let first result, so if there is, the first thing that you get back, if that's a result, so it's not nil, then we can essentially get the transform, so essentially the position and the orientation of that plane, to then form an AR anchor there. And I know this is kind of complex to go into, so let's walk it back a little bit. Once the raycast returns a result, we grab the first result. If this is our, essentially, this will be our horizontal plane, and that's where we want to place our object. To be able to place our object, again, we have to have an anchor entity. So we need to essentially have the location and orientation of this plane to align the anchor with that and then add the model to that. And so that's essentially what we're going to do. So we are going to say, in this case, we are going to now grab our code that we created to just randomly place our cube, and we're going to put that in our if statement. Now, important, we're not going to actually create our anchor entity with our plane alignment here. We're going to essentially create it in a different way. So what we're going to do is we're going to create an anchor entity, but we're going to use a transform. So we want to use a world transform. That's what we want to do. And our world transform is really the pose or the position and orientation of our detected plane at the point of the raycast. And so now we're going to say first result dot world transform. And that's how we essentially create our anchor entity. Now, in this case, we have an error that says unresolved identifier AR view. That's because we used a constant in the previous function. In this case, we're extending the AR view, so all we have to do is just do self, and that should work. Okay? So that's the way we would place the object. Now, if there for some reason is no result in our raycast, that will likely mean that there's no surface detected. And so just for good measure, we want to then create a message to the developer, or ideally the user, that the surface was not detected. So no surface detected, move around device. Now, this may only be an issue if you don't have a LiDAR sensor on your iPad or your iPhone. Any device that has a LiDAR sensor will be able to detect surfaces much quickly without having to move the device. So this should be it. Let's test it and see if it works well. Okay, so I'm gonna move my device around. See that we don't actually have any objects being placed right now, but if I tap on my surface, oops, oh, there's an issue. I forgot to call our enable placement function, and so nothing will be placed. So I'm going to actually call that. So enable placement. I'm going to say AR view dot enable placement. I forgot to call that. Now, if we don't call it, then the gesture recognizer is not added. So let's run this again. So we're going to move around a bit just so we can explore the horizontal surface. And then we're going to place our cube. And there we go. And the awesome thing now is that we can place multiple. And so we know that our advanced object placement is now working. In the first part of step 3, you learned how to do it in a simple way where it was just placed at any point where a horizontal surface is detected. And in the more complicated method, you saw how to actually have more control and place it wherever you tap on the screen. So that's step 3. For the final step, we're going to use a coordinator to enable the flow of data between a SwiftUI view and a UIKit view. In this case, we're going to allow the user to choose a shape for the object that they want to place. So they'll be able to choose between either a cube or a sphere. And so the UI, which is a SwiftUI view, has to be able to communicate that to the AR view, which is a UIKit view. And so a coordinator will be used to essentially allow bidirectional data flow between those two entities. So this step is a little bit more complicated. So I've actually created an outline with comments. And so that way I don't forget anything, and you can probably also follow it much easier. And so the first thing that we're going to do is we're going to create a enumeration where we can create multiple shape types. And so we're going to call this enum shape, and we're going to make it of type string and case iterable. We're making it case iterable because in this case, we want to be able to iterate over these shapes as we create our UI. And so that's why we're going to create it as case iterable. We're going to have a cube and we're going to have a sphere. And that is all we have to do for part A of this step. Now, what's next is we're going to look for part B. Let's find B. Okay, B. So B now goes into the SwiftUI content view to populate the interface. So that's what we're going to focus on. In this case, we're going to get all of our object shapes, and we're going to do this by saying shape.allCases. And this is why we wanted essentially our shape enum to be case iterable, because we can now get all of our shapes in just a simple array. Okay, and for part C, we have to create essentially a variable, a state variable that keeps count of which shape or which index in the array is selected. And so we're going to have an index variable that goes through the object shapes array to select the object shape. And so we're going to create a state variable. If you haven't seen a state variable before, this is a SwiftUI feature. And so I would advise you to look at state variables, binding variables, and also observables. They each have their uses, so make sure you go deeper into those concepts if you haven't before already. So we're going to do a private variable called selected shape index, and we're going to initialize that to 0. Okay, so now we have a state variable for SwiftUI where we keep track of the selected index, and we initialize this to 0. The next thing that we have to do is we're going to now refactor our vertical stack. We want to make the UI a little bit more sophisticated, and so we're going to use a Z-stack in this case, which is a lot of fun actually to use to build our interface. And so I'm going to delete our V-stack, and I'm going to create a Z-stack. Now, when you're creating a Z-stack, you can actually have an alignment property. And so what we're going to do is I'm going to select a alignment of bottom trailing. So I essentially want to automatically place objects near the bottom trailing. So you can essentially do it from the top, and so you can provide an alignment preference while doing that. And then when you have your Z-stack, then we're going to enter in our AR view wrapper, and we are going to redo our text hello. Actually, we're not going to do our text anymore. We're going to start moving into our final UI, and so we're going to shift to part E of this step. And so we have our AR view wrapper, and what we want to do on the bottom, but still overlaying on the AR view, we want to have a segmented picker. So to create a picker, what we're going to do is we're going to use the constructor to help us, because this is actually a pretty, it's a new way of creating UI elements. And so use SwiftUI and the autocomplete to help you along the way. And so we're going to use this constructor, which allows us to provide a title, which we're going to call shapes. And then our selection is a binding. So we're gonna pass a binding into our picker. A binding variable is essentially a property that has its source of truth outside of that view, or outside of that SwiftUI view. And so in this case, the picker does not really own the state variable, but it can access it. It has read-write capabilities to that property. And so we're gonna select the selected shape index as the variable, and you add a $sign in front of it to pass it as a binding variable. And then finally, we're gonna enter into content, and then it creates those two brackets. Now, in order to create our picker, we're gonna have to iterate over each shape option so that we can populate the picker. And so we are going to create a for each loop where we want to start at index 0, and we want to go up until but not including our object shapes dot count. So we essentially want to iterate over each shape. And in this case, we want to essentially get the index variable out of this iterator. So we want to obtain the index of each element out of this iterator. And then we're gonna set the text of the picker. So this is for each segment, we're assigning the text. We're gonna say self object shapes, and then we're gonna do raw value. Oh, we have to get the elements, so that's why we needed the index. We're gonna get the index from the iterator, and then we can go into our object and get the shape, and then the raw value. And then we're also gonna add a tag to it where we use the index. So we wanna tag each segment with the value of the shape, so 0, 1, etc. Okay, so that's that. Now, the final thing that we want to do is we have to select a picker style. And so in this case, we're going to select a segmented, segmented picker style. Okay, because there's multiple pickers. If you've ever done any app development, you know there's like a date picker, a segmented picker, and so there's many options. This is the basis of creating our more advanced UI. And so let's try to run it and see what happens. Okay, as you can see, it might be a bit hard to see, but there is a light bar on the bottom saying cube and sphere, and we can select between those two. So our picker is working. Now, in order to make it a little bit more visible and a little bit better designed, we're gonna add some modifiers. So in SwiftUI, you use modifiers to change the way things look and behave. And so what we're gonna do is we're gonna add our first modifier is, since it was so squished near the ends, we're gonna add some padding on all sides. And we're gonna add a padding of 10 pixels. And so it's gonna add a little bit more space. And then we also wanna add a background view, and we're gonna add a color, black. But to make it a little bit more elegant, we're gonna add some opacity to it. And we're gonna make this opacity, let's see, we're gonna make it 50% opaque. And this should style our picker a little bit more elegantly. And so we're gonna run it again. And now you can see it's much easier to see, it looks better, it just feels better. And so that's how simple it is to create your very own picker in SwiftUI. Now, for the hard part is to actually communicate the selected shape to ARView. Since ARView is a UIKit view, you can't just send that value over. If we were doing just in UIKit, that would likely be a callback, or we would have a delegate and we just fire the delegate. SwiftUI doesn't work that way. And so what we have to do is we're gonna scroll up top now. Let's find F, there we go. And we are going to create a coordinator. As I mentioned before, a coordinator allows you to essentially have a SwiftUI and a UIKit view communicate with each other. And so it is very important to understand this concept. It is almost comparable to a delegate. So it allows you to message a UIKit object. And so we are going to create a class called ARView coordinator. And in this case, we are going to inherit from NS object. NS object is the parent of many UIKit objects. And so most UIKit objects inherit from NS object, and so we're going to do the same. It'll make it more compatible. And then we're also going to use, in this case, before we continue, we have to import ARKit, because we're going to now adopt our AR session delegate protocol. And that's only accessible when you have ARKit imported, because this is an ARKit delegate. And so what we want to do next is we want to create our AR view coordinator. There's a few things that we have to create. So we're going to create two variables. We're going to create one. We're going to create a AR view wrapper. This is what's going to own the coordinator. So you can call it owner, parent, whatever. I'm going to be explicit and call it ARView wrapper, but that's the owner of the coordinator. And we are going to say that's ARView wrapper. And then we're also going to do a binding variable for the selected shape index. And this is a variable type int. Now we're going to create a constructor for this. And we're going to say ARView wrapper, which is the ARView wrapper. And then we're also going to say binding. Now, when you create a constructor, that's not how you do it. You do selected shape index, which is as a binding variable of type int. So that's how you essentially denote it. It's a little bit different than if you were to actually create the variable itself or declare the variable. And so we're going to initialize these two. We're going to say self ARView wrapper equals ARView wrapper. And then we're going to say self dot underscore selected shape index. So when you initialize a binding variable, you have to prepend it with an underscore. This is because it's a binding variable. And then we're going to say selected shape index, like that. Okay, so that's all we do. Now we want to have the ARView wrapper as a variable in the AR coordinator, because then we can essentially communicate and we have access to our AR view itself. And so that's why we make that a variable. Now, the next thing we're going to do is this is now part G of this step, is we're going to create a binding variable for shape index again, but this time in our UI view representable, which is our AR view wrapper. Let's see. So we're going to create a binding variable. And we're not going to actually create a constructor for this because when you create a binding variable, the constructor is automatically created for it. Now you can see an error though. We have an error in here that says cannot be used on instance. So it gave an error. Before it wasn't an error. What we essentially have to change, so this error is not really useful. We have to now use a different constructor for our ARView wrapper, and we're gonna now provide that the selected shape index, and then our error should go away. Right, so that error wasn't very meaningful, but by fixing the constructor of our ARView wrapper, now that we have a binding variable, that fixed it. Okay, so we're going to go back to G. That should be done. Now we're going to create a optional, but in this case we need it, a function that allows us to make a coordinator. And so our coordinator is going to, essentially this is automatically called by SwiftUI, and it's going to make our coordinator. So we're now going to return a ARView coordinator, and in this case we are going to instantiate it. So this is going to automatically create a coordinator for our UI view representable. Okay, so we're going to now say ARView coordinator. I'm going to create it. And we're going to make this self, and then we're going to add our binding variable, selected shape index, just like that. Okay, Then step I of this process, because we now have a coordinator in our UI view representable, we have to essentially let this coordinator know what to listen to. And so we're going to now say ARView session delegate. So our delegate now is our coordinator, and we're going to use that context.coordinator, which is provided by the make coordinator. So whenever something happens in our AR session, our coordinator is now notified saying, hey, this happened, handle it however you want to. And so that's very important. Don't forget this, otherwise nothing will happen, even though in our session things are happening. Okay, we're getting there. Now we're gonna do part J, which is we have to create a model function that takes in a shape and returns a model entity. So since we're now gonna switch between shapes, we can't just have code generating a box all the time. And so we're gonna create a create model function that has a shape parameter or argument, and will return a model entity. And so we are going to remove that part of the code where we created our mesh and our material, right? And in this case, we're going to do a conditional or a tertiary statement. We're going to say if shape equivalent to cube, question mark, then create a cube, else mesh resource, generate a sphere. Now this is only possible because we have two options. If you had multiple options, then this wouldn't be possible. You'd have to create a more traditional if or switch statement. And we're going to make this a radius of 0.1. Now we still have the same material, and then we're going to return our model entity, which uses a constructor of that one. So we're going to create our mesh there, and we're going to include our material. So now we have a function that gives us a model entity depending on the shape that we have selected. And so we can now go in here and say, okay, we're going to comment this out. And the way we're going to create our model now is we are going to, well, first we're going to have to create we're going to have to figure out what this shape is, right? What is our selected shape? And so, oh, I made one mistake. We're going to need our coordinator to be able to access our selected shape. So as you see in step K, now that we have our model generator or our model builder, we have to essentially get our coordinator. So we're going to do a guardlet statement for our coordinator, and we're going to say ARView, or self in this case, self session delegate as ARView coordinator. So we want to obtain our delegate, else. If we're unable to do this, then we can't actually access the shape. So error obtaining coordinator, and then we want to return. Okay, so now that we have our coordinator, what we can do is we can get our selected shape. And so we're going to do selected shape equals shape, all cases, and then we're going to do our coordinator dot selected shape index. Because now we have all of our cases again, right? And we can select our index, and we can just grab the shape that is currently selected by the segmented picker. Okay, and so now we can create our model entity, because all we have to do is now say create model, selected shape. Okay, so I think that should be all the code. Now let's test it to make sure it works. Okay, so we're gonna move around our space just to make sure that we map the environment. Now again, if you have the lighter iPad, you don't have to do this, but let's place a cube. That's awesome, it works. Now let's also add some spheres in our space. There we go, 1, 2, and then finally a cube. As you can see, the app works great. Now I hope you enjoyed making your very own SwiftUI and RealityKit app using only an iPad. Now if you have any questions about the code or the process, feel free to leave a comment down below, like the video if you really enjoyed it, and subscribe to see more videos like these.